So does anybody just raise your hand real quick? You don't have to say anything. If you remember doing synthetic division, that synthetic division existed, that you've heard those words before. Okay. So we're going to use synthetic division only when you divide by x plus a number or x minus a number. We're not going to have anything in front of the x, no powers, no nothing, but we'll start out with that one. So it's just going to have to be x in the front plus a number or x minus a number. That's the only time we can use synthetic division. Okay. So I'll work 2 synthetic division problems just to remind you of the process. And if you haven't done this before, it's really easy to catch on. This is really fun because you just get to do small addition and subtraction problems. So we're going to divide x cubed plus 2x squared plus 5x minus 1, and we'll divide it by x minus 3. It's helpful for us to divide polynomials so that we can factor them better. Because if you know one of the things that divides into it, you can figure out the rest of the factors pretty easily. If you're asked to do that ever. Okay. So the first thing that we look at is we see, is it possible to use synthetic division? Are we just dividing by x plus or minus a number? Yes, we're good to go. Okay. This is when we look at what is in here. What would be the root or the 0 or the solution if you had x minus 3? If you're trying to like graph that, what's your x-intercept or your root? What number would that be? That would be 3. That's what we're going to put in the box. So you're always going to put in the box what your solution would be. You don't just put -3. We're going to put what our solution would be. So in this case, we're going to put 3 in our box. So what would the x-intercept be if you're going to graph that? Okay. Then we're going to write the coefficients across from our original polynomial. You always have to make sure that you have a coefficient for each power that's present there. So we're going to make sure that we have a cube, a square, a first power, and a constant. Because if we're missing one of those, we'll have to put in a placeholder. Okay. All right. So the coefficient in front of x cubed is 1. In front of 2x squared is 2. In front of 5x is 5. And our constant is -1. So we just wrote our coefficients down. We made sure we had 1 for each power. Leave a space because we're going to fill the space in a minute and draw a line underneath that space. So we got a space here in the middle. And this is when the fun part comes in. I think so. I like to see how fast I can do it. I'm not going to go really fast for y'all right now, but just like when I'm doing it myself, I try to see if I can just have a race. But I guess no one else really cares. All right, so you're always going to take your first number here and you drop it down. It goes straight down to the bottom. Don't do anything else. Your first number gets dropped straight down. Okay. Once we do that, we're going to do this next process over and over and over again till we're finished. So we take the number on the bottom. We multiply it by 3. So the number on the bottom gets multiplied by the number in the box. So what is 1 times 3? 3. And we're going to put it here. Okay. And then we add them together. What is 2 plus 3? 5. Good. And now we repeat it. 5 times 3 is 15. We add these together and we get 20. Good. We multiply and get 20 times 3 is 60. Add these together and we get 55. 9. Put a box around 59. This is your remainder. That is what's left over. Okay? So when we write our answer, we're dividing a polynomial by another polynomial. So our answer is going to be a polynomial. So we've got to figure out what variables need to go with our numbers. So I always backtrack from here. So this is my remainder. I just think about how this is set up. The 20 is going to be my constant. The 5 is going to get the x, and the 1 is going to get the x squared. So the first one that you have is your remainder. Constant, x to the first, x to the second. If we had more, we'd keep increasing the powers. X to the third, x to the fourth, etc., etc. So when I write my full answer, it will be x squared plus 5x plus 20. And you can write your remainder in two ways. You can just say remainder 59, or we can make it a fraction. Plus 59x minus 3.
What's it gonna be on CUDA?
The fraction. Okay. All right, let's try another synthetic division one.
Why would you divide the 59 by the x minus 3?
It's just like when you're doing regular division, like if I said 10 over 3, your answer is going to be 3, right? What's the remainder? 1, right? You have a remainder 1, but it's really 3 1/3. You've got one part left of the 3, one of the 3. Same thing here. Our remainder is 59. We have to put it over what we divided by originally. It's like a fraction part. It's kind of weird when you have the polynomials though, but anytime you do that, that's your remainder. That's what you divided by. That was your whole number part. Okay, so our next one's a little bit different, but still synthetic division. I got x to the 5th minus 3x squared plus 4 divided by x plus 1. So x to the 5th minus 3x squared plus 4 divided by x plus 1. What is going to go in our box? What would be our solution if we saw this? -1, good. And then we're going to have some placeholders because I've got a 5th power, a 2nd power, and a constant. I'm missing some stuff in there, aren't I? I don't have all the powers that I need. So I'm starting with x to the 5th, so that's coefficient is 1. Is there an x to the 4th term? No, so I need to put a 0 for a placeholder. Do I have x to the 3rd? No. Do I have an x squared? Yep, so that's -3. Do I have x to the 1st? Nope, so I need a 0. And my constant is 4. So that's x to the 5th, 4th, 3rd, 2nd, 1st, and then the constant. You can think of these terms and these powers kind of like place values in regular numbers. Like, would you ever tell somebody that 14 is the same thing as 1004? No, so each of these spots is assigned a power with the x's. Constant, 1st, 2nd, 3rd, 4th, 5th. So if I just put 1, -3, 4, someone would think that was just a quadratic, that there were just 3 terms. So you've got to make sure that you have the placeholders in the right spot. Okay. All right, let's give this one a go. What are we going to drop down first? Our 1 gets dropped straight down. 1 times -1 is -1. Add those together. -1 times -1 is +1. Add those together and you get 1. 1 times -1 is -1. Add these together and we get -4. -4 times -1 is 4. 0 plus 4 is 4. 4 times -1 is -4. 4 plus -4 is 0. Okay, so our remainder is 0. Let's fill in the rest. Constant, I'll change colors so you can see the difference. Constant, x to the first, x to the second, x to the third, x to the fourth. So x to the fourth minus x to the third plus x squared minus 4x plus 4. Do I need to put any fractional part at the end? No, because the remainder was 0. I don't have to do anything else. And this is where it's pretty interesting just to know what this means if the remainder is 0. If you get a remainder of 0, that means that what you divided by, the x plus 1, is a factor. So that's important. So we know x plus 1 is actually a factor. That's going to help you break it down into different things. So we're just going to write that down. If the remainder is 0, then you found a factor, or what you divided by was a factor. And if we know that something is a factor, then we know that we can find one of our solutions or one of our x-intercepts. Because if x plus 1 was a factor, then -1 is going to have to be one of our x-intercepts. So we also found a 0 of the polynomial. If the remainder is 0, what you divided by is a factor, and we also get a 0 of our polynomial out of it. Before we do long division, I'm just going to show you how we can take some zeros, make factors out of them, and then write polynomials. So we'll just do one of those, and then we'll go on to long division. So that's important. So if somebody says, is something a factor, divide it and see if the remainder is 0. So occasionally they'll say, here are your roots, or here are your zeros of your polynomial. Actually write the polynomial now. So we're going to kind of backtrack for this. So if someone said my zeros are 2, -1, and 3, and they want you to write the polynomial, we're going to first put it in factored form, and then we'll do some distributing. So if you have 3 zeros, how many sets of parentheses are we going to need? 3. Okay. If our first 0 is 2, what would need to go in this parenthesis to ensure that we got 2 as one of our roots or solutions as 0? A minus, right? So x minus 2. What's going to go in the next one? A plus 1. And the next one will be a minus 3, right? So it's basically going backwards from what we did last time. But now you want to actually multiply these out. So just start with your first 2 and FOIL them. And then once we get that, we'll multiply by the last one. So X times x is x squared. X times 1 is x minus 2x minus 2. Combine those in the middle, which is x squared minus x minus 2. Everybody agree? My formula okay? And then we just multiply the x squared minus x minus 2 times the x minus 3. Distribute again. So x squared times x squared times minus 3. Then move on, negative x squared plus 3x minus 2x plus 6. Y'all finish that off real quick, combine those like terms, and we'll see if we get the same thing. So I'll get x cubed minus 4x squared plus x plus 6. All right, so if someone asks you to do a polynomial, you can do that. I'm not going to multiply this next one out. I just want to show you what happens if one of your zeros is actually the number 0. So what you would do in that case. So if they said something like your zeros are 0, 3, and 5. If your 0 is 0, you don't need a parenthesis. You just need the letter x, right? If you have an x in the front, then that means your first one is going to be 0. That we saw that yesterday. And then x minus 3, x minus 5. So if you have a 0 of 0, that just goes as a regular x. You could say x minus 0 if you want, but it's just going to simplify. Okay. All right. Are we ready to long divide? Yes. The process for long division for polynomials is the exact same process as long division for regular numbers. So let's just kind of recall what that is, just to make sure that everybody's clear. If I had, let's just do a kind of a basic long division. We're going to do 7 divided by 4,328. Just made it up. We'll just see how it goes. Just giving you guys flashbacks, nightmares through the 4th grade. Yeah, it's not that bad. So we always look first. Does 7 go into 4, this first number? No. So does 7 go into 43? Yes. And how many times? 6. Okay. So 6 times 7 is 42. And we subtract them, right? 43 minus 42 is 1. And what do I do with this 2? I bring down the 2. Okay. And now I repeat it. 7 goes into 12 how many times? Once. 1 times 7 is 7. I'll subtract. 12 minus 7 is 5. I bring down the 8. 7 goes into 58 8 times. 8 times 7 is 56. Subtract them and you get 2. We don't have any other numbers to bring down. I mean, you could do decimals if you wanted to, but we have a remainder of 2. So we can say 618 remainder 2, or 618 and 2/7. So 7 times 618 and 2/7 would give you 4,328. Okay. We're going to do the same process with polynomials. We see how many times it goes in there. We multiply, subtract, try it again, bring the stuff down. But it's just those rather than the other. Y'all ready for it? No? Yes? Maybe so? Okay, so our first one we're going to do is 2x plus 1. We're going to divide this into 4x cubed plus 2x squared minus 2x minus 3. Why am I using long division instead of synthetic division on this problem? What's making it where I can't use synthetic division?
The 2x.
The 2 in the front of the x, yeah. Okay. So here we go. If you want to just watch me and then write, I'll let you give you time to write it down afterwards if you just kind of want to see how this goes. So for these, we're always going to look at what's at the very beginning, here and here. So if we're thinking 2x goes into 4x cubed, when you're saying goes into, you kind of want to think 2x times what gives you 4x cubed. So 2 times 2 gives me 4, and x times x squared gives me x cubed. Is that okay? Are we okay with that? So if I multiply 2x squared times 2x, I'm going to get 4x cubed. So I figure out 2x times what is going to give me this number at the beginning. We're only concerned about our first terms when we're doing these. So we figured out what goes there. Now we're going to do our multiplying just like we did in regular long division. So 2x squared times 2x is 4x cubed. And then 2x squared times 1 is going to also give us 2. Well, it's going to give us 2x squared. And now we're going to subtract. And this is where people mess up because they forget that they're subtracting this whole thing. So I put parentheses around it. There's never going to be anything left at the beginning because we made it match exactly. So there's nothing there. Okay. I've got 2x squared minus 2x squared, and that gives me 0. All right. Let me drop down my next thing. Because this was 0, this one's kind of a little bit strange, but because this is 0, if you want to drop down both of the remaining items, you can go ahead and do that because the 0 is not going to give us anything to divide by. You always, if I had 2 terms here, you're going to want to have 2 terms to put your numbers underneath. So let's go ahead and drop down this minus 3. Normally we just do 1 at a time, but just because that was a 0, we'll have to do that. So we don't really care about that 0. It's gone. And we'll repeat our process. 2x times what gives me negative 2x? Negative 1, right? Okay, so negative 1. Negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. And we're going to subtract them. Negative 2x minus negative 2x, nothing's going to be there. What is negative 3 minus a negative 1? Negative 2. Negative 3 minus a negative makes a plus 1, right? So this is like negative 3 plus 1. You've got to pay attention to this, minus a negative. 2x cannot multiply by anything to give us negative 2. So this is our remainder. So I'll just put plus -2 over 2x plus 1. We'll do one more. It's got 3 terms in the divisor, dividend. I don't ever remember which is which. Anybody know which one of these is the divisor and which one's the dividend? No? Okay.
The divisor is what you divide by, right?
Divide by, and that's the dividend.
Yeah.
Yeah, the dividend is on the inside.
Got it. I skipped a lot of those elementary math grades, so where they taught all that vocabulary. Let's see. All right, so the next one that we're going to do is a quadratic dividing into a quartic. So we have x squared plus x plus 3, and that's dividing into 3x to the 4th minus 5x cubed minus 20x minus 5. I went ahead and just wrote it in this form, but you would be giving it to you in this divided by that, and you've got to figure out if there are any placeholders. But I just went ahead and added your placeholder here. So if you didn't have an x squared term in this one, go ahead and put 0x squared and make sure it's in the right spot. Otherwise, when you're lining things up and dropping them down, it's going to get all messy. So you have to make sure you have placeholders in these as well. Okay. All right, let's see how this goes. It's our last one. We look at our first terms. X squared. How are we going to turn x squared into 3x to the 4th? Well, we're going to multiply it by 3x squared. Thumbs up if you agree. That works? Okay. And now we'll multiply all of our terms and put them underneath. 3x squared times x squared, 3x to the 4th. 3x squared times x, 3x cubed. And 3x squared times 3, 9x squared. Once we have those, what are we going to do next? What's our next step? Subtract. When in doubt, if you're like, I don't know what step to do, just think about your elementary subtraction. Not subtraction, division, I mean. And you would know what to do. Okay, so this is always going to go away. We set it up that way. So we're going to look at the next one. Negative 5x cubed minus 3x cubed. Negative 5 minus 3 is negative 8. Right? 0 minus 9, negative 9. And then we need 3 terms because we had 3 terms over here. So we're going to drop down our 20x, or negative 20x. Everybody good with that? Okay, we do it again. To get x squared to negative 8x cubed, I need a negative 8, don't I? And do I need just a single x? Negative 8x times that would give me this. Good. Okay, so now we're multiplying again. Negative 8x times x squared is negative 8x cubed. Negative 8x times x is negative 8x squared. Negative 8x times 3 is negative 24x. Time to subtract again. Those will be gone. Negative 9 minus negative 8. Negative 1, good. Negative 20 minus negative 24. Plus 4. And then we drop down our minus 5. All right, if negatives are not your favorite thing to deal with, just put that in a calculator when you're doing it. -9 minus -8, or -20 minus -24. You can do that. All right, and then we go one more round. Should be all that we can do, right? X times what is -1x squared? -1. -1 times x squared, -1x squared. -1 times x, -1x. -1 times 3, -3. We subtract again. 4 minus -1. 5x, good. -5 minus -3, -2. There's nothing left for us to drop down. I can't take x squared and turn it into a 5x anyway. So this is my remainder. If your power that you're dividing by is more than the first power, your remainder is normally going to be 1 power lower than that, because you wouldn't be able to divide it. So 5x minus 2 goes back up here in our little fraction. So plus 5x minus 2 over x squared plus x plus 3. Do you see where you could make some mistakes on these long division problems? With all of the addition and subtraction, yeah, you have to be really careful with those. So if you don't get the answer on CUDA, just think, oh, I probably subtracted or added something wrong for that part of it. All right, you guys are free to start dividing. Raise your hand if you've never seen the long division before you start going. Anybody never seen the long division? Not in regular numbers, but in polynomials, if you have not done that before. Okay. Madison, you haven't done it before.
Can I use the bathroom?
Sure, Cedric. Cedric, you never did long division before either. We didn't do it last year.
Yep.
Yeah. So Grace, you didn't either. Right, just make sure your cameras stay on and I can see you and see that you are working. I like to watch your faces when you do math in your head. It's like this, a lot of scrunched up faces.